Now we will discuss the Nikon NPL 352 equipment. First, we will unpack the box and identify all the equipment that is the current FEMA cache. Keep in mind that there are two sets of these items, as there are two Nikon NPL 352 instruments in each cache. Items located in the case are Nikon NPL 352, Mini Prism, Pole and tips, batteries and charger, 12-volt to 110-volt power inverter, right angle or zenith eyepiece. The right angle eyepiece can be installed for using the instrument to monitor at steep angles, such as might be the case when instrument setup is close to a tall building. The existing eyepiece must be unscrewed from the unit and placed onto the sighting end of the right angle eyepiece. Also in the case is the Nikon NPL 352 manual and rain hood. Now that we have discussed the items found in the box, we will review the various features and key functions on the Nikon NPL 352 total station. There are two faces on the instrument. Face 1 has the following features: an optical sighting pointer, also called the optical sight finder in the Nikon manual, a telescope focus ring, which focuses the target image, an eyepiece focus ring, which is used to adjust the clarity of the crosshairs, a plate level, a horizontal tangent screw, also referred to as the upper plate tangent screw in the Nikon manual, a vertical tangent screw, and the bullseye level, which is also called the circular level. Face 2 of the instrument has the optical plummet eyepiece, which enables you to set the instrument over a known point. There are two focusing rings on the optical plummet called the optical focus and the crosshair focus. The outside ring is used to focus the telescope on the object you are setting up over, and the inside ring focuses the crosshairs. Each face has the same keyboard or button layout and display. Various main keys that will be used include the power key, which is the red key in the upper right-hand corner, and the menu key, which displays the menu screen and is discussed in more detail later. Other keys are the mode key, which changes the key input mode between alphanumeric and numeric. The hot key, which displays the hot menu, which includes height of target, temperature and pressure, target notes, and default points. The Rec Int or Record Enter is the yellow key in the lower right-hand corner and is used to record or enter data and information. The ANG or Angle key displays the angle menu. The DSP or Display key is used to scroll through the 4 display screens that will be discussed in more detail later. The MSR1 and MSR2 keys are used to take measurements while in the BMS or Basic Measurement screen. The ESC or Escape key is the yellow key in the lower left-hand corner and is used to undo the entered work or return to previous screens. Different settings and menu screens can be accessed by using the 1-second keys. These keys are the MSR1, MSR2, DSP, and ANG keys. The settings or menus screens are displayed by holding these keys down for 1 second or more. One other feature is the battery condition charge icon. The battery condition level is indicated by this icon located in the lower right-hand corner of the display screen. The capacity of a fully charged battery in good condition will generally be longer than a 12-hour shift. When finished with operations, you must place the Nikon NPL 352 back in its case. The procedure is fairly straightforward. A few items to note are debris and moisture on the instrument, specifically the face, and behind the battery. If the instrument has moisture on it, place it in the box with the lid open in a protected environment. When placing the instrument back in the case, adjust the level screws to the center of the screw range. The center of the screw range is indicated by a small groove on the shaft of the leveling screws. Put the telescope in the face 1 position and place the instrument in the box with the battery up. Ensure the arrow below the battery is in line with the arrow on the base plate. Place the remaining items back in the case, taking care not to jam the instrument with the smaller parts. It is important to note that the manufacturer's recommendation is to store the instrument without the battery connected and to charge the battery separately outside of the case. As the urban search environment requires immediate response, it has been decided to store the instruments with a full battery and carry the spare battery and charger to the site in the case. Setting up the total station over a known point. With practice, this can be accomplished in well under 5 minutes by following these steps. These steps are also outlined in Section 5 of your US&R Field Operations Guidebook, or FOG. 1. Loosen tripod legs, and with the legs together, extend the height to just below your chin. 2. Tighten clamps or thumb screws on the legs, finger tight only, and spread the legs with the leveling plate approximately level and over the known ground point. The front leg should point towards the structural feature or point to be monitored. Set that leg by stepping onto the footplate. 3. Secure the total station onto the tripod. Again, finger tight only. 4. Look through the optical plummet and align the bullseye over the ground point by lifting and sliding the 2 back legs of the tripod. Once the bullseye is at least partially centered over the point, set the back legs. 5. Look at the bullseye level and begin leveling. Determine which of the 2 back legs needs to be adjusted. Grip the upper tripod leg just above the lower leg. Loosen the screw and adjust the height to move the bubble into the center of the bullseye. Repeat with the other leg until the bubble is centered. 6. Using the plate level bubble, use the leveling screws to fine level the instrument, first in the direction of 2 screws, then perpendicular to that using the other screw. 7. Resight the ground point using the optical plummet. If the instrument is not centered, loosen the base and gently slide. Do not rotate the instrument to center the bullseye over the point. The instrument is ready to use. The Nikon NPL 352 is equipped with electronic level compensators. These compensators will correct readings to true level when the instrument is within 3 minutes 30 seconds of level in each direction. Normal urban search and rescue operations should use the level compensators. However, there may be occasions when the compensators should be turned off, such as working on sites where there is excessive vibration, heavy trucking, set up on a bridge, etc. Excessive vibration interferes with the functioning of the angle compensators, complicating the measuring process. To turn the compensators off, use the following steps. 1. With the instrument turned on. 2. Press the level vial key, 0 numeral. 3. Press the up or down arrows until the out-of-level values are replaced by the words off in both directions. To turn the compensators on, use the following steps. 1. With the instrument turned on. 2. Press the level vial key, 0 numeral. 3. Press the up or down arrows until the words off are replaced by out-of-level values in both directions. When you sight the instrument, you aim the telescope at the target, bringing the target image into focus, and align the image with the center crosshairs of the reticle. To eliminate parallax, aim the telescope at the target image. Rotate the focusing ring until the target image is in sharp focus on the reticle crosshairs. Move your eye vertically and laterally to check whether the target image moves relative to the reticle crosshairs. If the target image does not move, there is no parallax. If the target image does move, rotate the telescope focusing ring and move your eye vertically and laterally again to check whether the target image moves relative to the reticle crosshairs. The screen contrast, backlight function, and sound can be accessed using the backlight key, located just left of the power button. To toggle the backlight on and off, press the backlight key. To access the other functions, press and hold the backlight key for more than 1 second. To adjust the contrast, press the left or right arrow key, then scroll up and down using the up and down arrow keys to adjust the contrast. Then hit the left or right arrow key to return to the previous screen. To turn the backlight on and off through the menu, press the Record Enter key, which toggles the backlight on and off. To turn the sound on and off, scroll down to the speaker icon and press the Record Enter key, which will toggle the sound on and off. To get out of this menu, press Escape. This section will show how to start up the Nikon NPL 352 and use it as a theodolite, and presents the various screens on the Nikon NPL 352. After setting up and leveling the instrument, turn on the instrument using the red key in the upper right corner. The first screen that comes up lists what the Nikon NPL 352 reads as the current temperature and pressure. If these values are not correct, they should be changed prior to tilting the telescope. To do this, press the Enter key and set the temperature. Press Enter again to set the pressure. Press the Enter key to input it. Now, tilt the telescope up and down slightly. If the temperature and pressure are correct as initially displayed, you can skip these steps and just tilt the telescope to begin. Tilting the telescope will bring up the basic measurement screens, unless the instrument is not leveled within the tolerance range of the level compensators. In the event that the instrument gets bumped, moved, or otherwise compromised, the out-of-level screen will display. This screen can also be accessed by pressing the 0 key on the numeric pad. Fine leveling is done using the 3 leveling screws under the leveling plate. Again, return to the BMS screen by using the Escape key and tilt the telescope to establish the 0 zenith vertical angle. Remember that the angles will likely have changed as a result of being out of level. There are 4 BMS screens which are viewed in order by pressing the display key repeatedly. If the instrument is only going to be used as a theodolite, only the first screen is needed. Located on the upper right-hand corner of the screen is a screen indicator showing one of 4 screens. That is the first screen. The other 3 displays are shown as follows by pressing the display key: 2 of 4, 3 of 4, and 4 of 4. The horizontal and vertical angle values in the screen will change as the instrument is sighted on a monitor point, and these values must be written down in a logbook or on a monitoring form. They cannot be recorded until a job has been created in the instrument. Monitoring points while in the theodolite mode is done by sighting on a point to be monitored and recording manually the horizontal angle and the vertical angle. Several points can be monitored this way as long as the instrument is not moved. It is convenient to establish a reference point to set as the position of 0 horizontal angle. This is commonly referred to as the back sight, although the back sight is often located forward of the instrument. The horizontal angle is set to 0 through the Angle menu, which is accessed by pressing the ANG key. Scroll to the 0 set option and press the Record Enter key or press the 1 key. This will set the current orientation of the telescope as the 0 horizontal angle. Points to be monitored are sighted and their horizontal angle and vertical angle recorded on monitoring forms or field books. Once the horizontal and vertical angle are known, the points can be monitored by turning the telescope back to the last recorded location, using the tangent screws of the instrument until the output screen of the instrument has the desired readings. After returning the instrument to the prior recorded horizontal and vertical angle settings, the object is sighted through the telescope, and movement can be immediately ascertained by seeing if the crosshairs of the telescope are still centered on the point being monitored. It should be noted that the accuracy of a 5-second survey instrument is approximately 1/8 of an inch for a point 400 feet in distance. Although the Nikon NPL 352 is rated as a 5-second machine, its performance is always better than this. The level of accuracy should be more than sufficient for the purposes of monitoring points in the urban search and rescue environment. An important note: if using the Nikon NPL 352 strictly as a theodolite, and due to rescue operations it becomes necessary to pick up and move the instrument, the STS has two options to continue monitoring the same points. If returning to the original setup point, the instrument must be set in the exact location as before, or the horizontal angle and the vertical angle measurements will be different. As setting up in the exact location is highly unlikely, it is best to take new horizontal and vertical angle measurements and record them in your logbook or monitor form while noting that the instrument was relocated. Initial instrument configuration. The Nikon NPL 352 total station needs to be configured prior to being used to measure and record data or being used as a total station. Some settings are set once at the beginning of a job and cannot be changed. These items are referred to as job settings. They are set from within the menu screen under the Settings heading. To get to this, press the menu button and then either scroll down to the settings or press number 3 and press Record Enter. Items such as prism constants, temperature, and pressure can be changed as equipment and conditions change. These are referred to as variable settings. These are set from within the hot MSR1 and MSR2 screens. To get to these screens, press and hold down MSR1 or MSR2. All settings should be checked prior to establishing a new job to prevent errors. Variable settings should be checked occasionally during use to verify that they have not been reset inadvertently. Next, we will discuss setting up a station. Setting up a station means establishing an instrument's location in a three-dimensional space. This location can either be set arbitrarily, where the user will establish a new grid reference system, or it can be tied into an existing grid reference system. This is one of the powerful attributes of a modern total station. If a new grid is to be established, some thought must be given before creating the first station. The desired orientation of the new grid will depend on a suitable backsite being selected. The backsite can be a prism or a reflector foil or even a Phillips head screw on a wall plate. The current consensus is that for urban search and rescue use, a grid that follows that of the structure being monitored is desirable. This requires that the zero azimuth or horizontal angle be roughly perpendicular to one face of the structure. The second item is deciding the basic coordinates of the station to be established. Keeping the coordinates for different axes substantially different, for example 1,000 for the x-axis, 100 for the y-axis, and 10 for the z-axis, will help prevent confusion when determining the magnitude and direction of any building movement. Remember that the station being created is a point on the ground below the instrument, so that the instrument can be removed and brought back into its position within the 3D grid established. Access the Station Setup menu by pressing the 7 key while in the BMS screen. In this Station Setup menu, there are 7 choices to pick from. To see the final 2, scroll through the menu items until you reach the second screen. In the initial Station Setup, we will use Option 1, Known Point. When re-establishing the location of a total station on an existing coordinate grid, it is preferred to set up over a previously established point. It is possible to establish a station on an existing grid at an unknown location. Pressing the 1 key or the Record Enter key when the known item is highlighted brings up the Input Station screen. If this was an existing coordinate grid with known points, it is easy to enter a known point and the total station would use the point's stored coordinates. Since we are demonstrating how to establish a new grid, we will need to enter the station's known arbitrarily set coordinates. The total station is set to number all of the points sequentially, so we will start this station as 10. We will use x, y, z coordinates of 1,000, 100, and 10 feet. We will set the actual height of the instrument at 5 feet. Enter the ST as 10 and press Record Enter. This brings up the coordinate input screen for point 1. This means your first point. This is not the station number that you entered. Enter the value for x as 1,000 feet and press Record Enter. Enter the value for y as 100 feet and press Record Enter. Enter the value for z as 10 feet and press Record Enter. At this time, we are not covering the use of the point codes, the CD entry. Therefore, this line can be left blank. Pressing Record Enter scrolls through and brings you back to the Input Station screen. The height of instrument is entered, and pressing the Record Enter key will bring back the Backsight screen, which is needed to orient the coordinate grid we have just created. We have selected a point to use as a backsight on the structure we are going to monitor, which lies on a line roughly perpendicular to the structure. We will set the horizontal angle to this point to be our 0 horizontal angle. To do this, we select Option 2, Angle, and press Record Enter or the 2 key on the numeric pad. Note that this backsight is not the same as a backsight in a traverse. This is the point that we are sighting to set our angle or azimuth to 0. If we were using a point known to the total station, we would enter the point's number on the line for backsight. It is not necessary for this to be a point with known coordinates, only a point that we can find again to re-establish the grid orientation. This being the case, we do not have to identify the backsight and can skip this entry by pressing the Record Enter key. We are establishing that this point lies on the 0 horizontal angle, so enter 0 for azimuth and press the Record Enter key. This brings up the screen which sets the orientation of the 0 horizontal angle. The backsight point that has been chosen has been sighted through the telescope, and the MSR key which corresponds to the type of reflector being sighted, either reflector or reflectorless, is pressed. This measurement sets the horizontal orientation of the grid. Pressing the Record Enter key completes the station setup process. Note that when Enter is pressed, the coordinates of the backsight are not saved. This point must be measured and saved. The total station is now ready to measure and record points referenced to a known grid with a known orientation. It is now possible to dismantle the instrument and reinstall it at this point, and knowing the backsight, be able to re-establish the total station relative to this grid in 3 dimensions. Now we will discuss creating a new job. Assuming that the instrument has been set up and leveled, and that the basic settings have been established, and that the measuring keys have been configured, the use of the total station as an EDM and data logger can proceed. The first step is to create a job, which is basically a data file with specific settings pre-selected as discussed earlier. The job function is accessed through the menu key, which is reached by pressing the menu key. Scrolling to the job function and pressing Record Enter or pressing 1 on the numeric pad will bring up the Job Manager window. Note the soft keys Create, Delete, Control, and Info at the bottom of the LCD display. Pressing the MSR1 key, which corresponds to the Create soft key, brings up a window in which a job name can be customized. Add text creating the job name. Pressing the Record Enter key brings up the Create Job window. Again, note the soft key choices. The Settings key allows the last chance to verify that the settings are correctly established prior to creating the job. Check the job setting by pressing the Set soft key. The default urban search and rescue settings are Scale 1.0, Temperature pressure correction on, Sea level off, Curvature and refraction correction 0.132, Angle degree, Distance US feet decimal, Temperature 0 degrees Fahrenheit, Pressure inches mercury, Vertical angle 0, zenith, azimuth 0, north, Order ENZ, easting, northing, and zenith, Horizontal angle, azimuth. Pressing the angle key, which corresponds to the OK soft key, finishes the process of the job creation and returns back to the BMS screen. After opening a newly created job, access the Station Setup menu by pressing the 7 key while in the BMS screen. In this Station Setup menu, there are 7 choices to pick from. Scroll down to see the last 2. For this case, we will use option 1, Known Point. Pressing the 1 key or the Record Enter key when the known item is highlighted brings up the Input Station screen. We will number this first instrument station, which is also a control point, as 10. We will enter the station's known arbitrarily set coordinates. Enter the value for X as 1,000 feet and press Record Enter. Enter the value for Y as 100 feet and press Record Enter. Enter the value for Z as 10 feet and press Record Enter. We will name this point CP10-IP1 for Control Point 10, Instrument Point 1. Press Enter, and we are asked for the height of the instrument from the point on the ground to the crosshair on the side of the instrument. We measured the actual height of the instrument at 5.25 feet. Pressing the Record Enter key will bring back the Backsight screen, which is needed to orientate the coordinate grid we have just created. We will number this backsight 5 up from our IP station number, which in this case is 15. Again, note that we have selected a point to use as a backsight on the structure we are going to monitor, which lies on a line roughly perpendicular to the structure. We will set the horizontal angle to this point to be our 0 horizontal angle. Note that this backsight is not the same as a backsight in a traverse. This is the point that we are sighting to set our angle or azimuth to 0. The backsight point that has been chosen has been sighted through the telescope, and the MSR key, which corresponds to the type of reflector being sighted, either reflector or reflectorless, is pressed. This measurement sets the horizontal orientation of the grid. Pressing the Record Enter key completes the station setup process. Note that when Enter is pressed, the coordinates of the backsight are not saved. This point must be measured and saved. The total station is now ready to measure and record points referenced to a known grid with a known orientation. It is now possible to dismantle the instrument and reinstall it at this point, and, knowing the backsight, be able to re-establish the total station relative to this grid in 3 dimensions. We've been monitoring a point on a building. We've set a couple of control points, and we've been told we have to relocate the instrument to monitor from a new location. So we've broken down the instrument, moved it over. We just finished leveling it, setting it up. We're going to turn it back on, and we're going to re-establish ourselves in the grid that we had established for the other instrument location. Turn on the instrument and follow the instructions to tilt the telescope. Using the Menu button, open up a job. We want an existing job, so we will select the job we had open previously. Press the Station key, number 7, which brings up the station screen. We're going to use the Known Line method, which is option 7 in the submenu. After selecting, the instrument requests us to input point 1. The first point we want to use is Control Point 20, which has been previously saved, so we'll enter point number 20. A dialog box displays the coordinates for this point. After verifying that these are the correct coordinates, press Enter. The instrument then requests the height of target, which in our case is 0 because we're using a non-prism mode to shoot a known object. The instrument then tells you to sight on point 1 and press the measure key. It comes back with the readings for that location based on where the instrument is now set up. It tells you to press Enter to continue, so press the Enter key. And now we have two options for how to continue for our second point. We can do it by angle or by coordinate. For this option, we're going to use by coordinate. We're going to enter another control point, number 30, that we know the coordinates of, and the instrument displays the coordinates for that point. Again, after verifying the coordinates for that point, press Enter, and the instrument again requests the height of target, which is again 0. It's not a reflector, and will sight on that point. Once sighted on the control point, press the measure key and press Enter to finish. Our new instrument point location is now recalculated and displayed on the screen. After verifying this new instrument location, press Enter to validate it. It is important to understand that this position is to the center of the instrument, not to the ground, so press Enter to record it. As this is the second instrument point, but not a control point, we number this point 12. If we are interested in recording the station point on the ground and not just the location of the instrument, we will input the height of instrument. But this is one place where error can be introduced into the system, so we suggest not inputting a height of instrument value and keeping the IP2 point at the center of the instrument. The name of this new instrument point is IP2, so we input that into the code line. We are then asked which of the 2 points the instrument should utilize as a backsight. Pressing the DSP or change soft key brings up the 2 points we use to establish our new instrument location. Either point can be used, but it is suggested to use the point to the left of the new instrument location. We are now ready to go back and measure our monitor points. Of course, it is desired that the measurements from the second instrument point will match the measurements from the first instrument point exactly. This is often not the case, and the coordinates are typically a couple hundredths of a foot off. These new coordinates should be noted in both the monitor form and field book, with a comment detailing that they were obtained from a new instrument location. Now that the total station is set up and the job has been created, measuring and recording point data is straightforward. To review, we have set MSR1 and MSR2 to measure in either prism or non-prism mode. For prism mode, we have input the prism constant noted on the side of the prism. We have set up the instrument in a location that has unobstructed view of the monitor point and anticipates the direction of movement we are trying to detect. We have created a job, set all of our variables within that job, and set the instrument station as 1000, 100, 10. We have established a few control point locations in case we need to relocate the instrument to a new location. We have unobstructed view to at least 3 of these control points. Let's now go through the steps required to measure and record the data for these established points. After the job has been opened and the instrument station established, we need to take one measurement of our monitor point. This will establish the baseline, and after all is why we have been asked to monitor. Sight the monitor point and press MSR1 or MSR2 depending on the target. Most of the time you will be monitoring a specific piece of a structure, and the measurement will be taken in non-prism mode. So we sight the monitor point and press the appropriate MSR key. In this case, MSR1. The instrument sends out the laser pulse and reads the distance and coordinates. Note the 0 mm symbol going across the screen during measurement and the NP along the right-hand edge of the window. These both let you know that you are measuring in non-prism mode with a prism constant of 0 mm. After the instrument has finished measuring, it will display the coordinates and distance information of the measured point. When you press the Record Enter button, the instrument brings up the Data Entry menu. Here you can renumber the data point and/or name it as well. It is important to remember that the Nikon NPL 352 will increment that last known data point for each measurement. As our last point entered was number 10 for the instrument location, the instrument wants to assign 11 as the next measured point number. Simply highlight the number by pressing the up or down keys and change this number. For our purpose, we number monitor points in the hundreds. As this is our first monitor point, we will number this point 100. Subsequent measurements of this point will be 101, 102, 103, and so on. Height of the target, or HT, is 0, as we are shooting directly at our target. We want to name this point MP100, so we scroll down to the CD line and input MP100 on this line. Then press Record Enter to accept and store the information. After measuring and recording the first monitor point, we are then ready to measure and record our first control point information. We sight on the first control point and repeat the same procedures as before. Sight the control point and press the appropriate MSR measurement key. After the instrument has finished measuring, it will display the coordinates and distance information of the measured point. We number control points in the tens, with our first control being the instrument location and numbered 10. So we number this control point 20. Height of the target is again 0 if we are shooting directly at the target. If you are using a prism with or without a pole, you will need to input the height between the actual target and the center of the prism that you are measuring. For this case, we are directly shooting at the target, so our height of target is 0. We scroll down and call the point CP2 and press Record Enter to accept. Then we go back to sight on the monitor point to be sure it is not moving. Follow the same steps as before and record the second measurement. Sight the target, press the MSR key, and input the number and name of the measurement data. We have to change our number again, this time changing it to 101 as we are measuring monitor point 100. Change the name on the CD line and press Record Enter to accept. Then we go and sight on our second control point, which is again a direct shot of the target. We number it 30. Name it CP3 and press Record Enter to accept and record. After you have established at least 3 control points, repeated measurements of the same monitor point is very straightforward. Just press the MSR key. Then press the Record Enter key. Between these measurements is also a good time to log the data on the monitor form or in your field book. Press Record Enter to accept and record. Again, just press the MSR key. It is important to note that if the instrument keeps beeping and doesn't display the measured data information, it is not able to reflect the laser pulse off of the monitor point. This could happen if you are trying to monitor a corner of a building and the laser is reflecting off of the corner but not back to the instrument. In this case, you will need to come back onto the building a little bit, to a spot that will reflect the laser back to the instrument. Press Record Enter to accept and record. Sight the monitor point. Press the MSR key. Then press the Record Enter key. Sight the monitor point. Press the MSR key. Press the Record Enter key. If we are requested to start monitoring a second point, we simply sight on it, press the appropriate MSR key, Change the name to MP200. Change the number to 200. Then press Record Enter to accept. For subsequent measurements of MP200, we follow the same steps as before. Sight the point. Press the appropriate MSR key. Then press the Record Enter key. Sight the monitor point. Then press the MSR key. Press the Record Enter key. Sight the monitor point. Press the MSR key. Press the Record Enter key. To bring the recorded information up in order to review or write it down on the form or in your field book, press the DAT or Data key and use the arrow keys to highlight XYZ and press Enter. Scroll through the list of recorded data. Highlight the one you want and press Enter. Once the coordinate data is displayed for one point, press the up or down arrow keys again to scroll through the screens to view the XYZ coordinate data of each data point. Press the Escape key to back up through the screens and return to the basic measurement screen. After we have recorded the measurement of monitor point 2, we will go back to measuring and recording monitor point number 1. Sight the point. Press the appropriate MSR key. It is also important to remember to go back and take additional measurements of your control points to ensure the instrument has not moved or been bumped out of level. Press the Record Enter key. Sight the monitor point. Then press the MSR key. Press the Record Enter key. Sight the monitor point. Press the MSR key. Press Record Enter to accept and record. Now that we have measured and recorded our data, we want to be able to review and edit this data if we need to. We bring up our data by pressing the DAT or number 6 key. This displays our raw data point numbers and the names that we input into the code line. By pressing the down and up arrow keys, we can scroll through the list to select the point that you want to view. The initial display is horizontal and vertical angle and the measured slope distance. Pressing the arrow keys again scrolls through the list and brings up information for the next point in the stack. Pressing the DSP key brings up the X, Y, and Z coordinates of the points. Again, scrolling through the list displays data for the other points stored in the stack. We can also press the MSR2 or Edit Soft key and edit some information for each data point. The options available for editing are point number, height of target, and name input into the code line. Scroll through each line and edit the information. Then press the ENT key as requested, and the new information is recorded for that data point. We can also delete the data points from the stored memory if required. This is accomplished by pressing the MSR1 or Delete Soft key and confirming the request when prompted by the instrument.